Good day, everyone. I am Reina Marie de Bisaya, and I'm going to discuss the 5 selected items from our final problem set. For our first item, we are going to find the derivative of the function. The function f of x equals the natural logarithm of the inverse tangent of 3x. The function f of x equals the natural logarithm of the inverse tangent of 3x. The derivative of the natural logarithm of a function is 1 divided by the function multiplied by the derivative of that function. F prime of x equals 1 divided by the inverse tangent of 3x times the derivative of the inverse tangent of 3x. The derivative of the inverse tangent of 3x is 1 divided by the quantity 1 plus 3x squared multiplied by 3. Now, let us substitute back. Substitute the derivative of the inverse tangent into the equation. F prime of x equals 1 divided by the inverse tangent of 3x multiplied by the quantity of 3 divided by 1 plus 9x squared. Now, let us simplify. Combine the terms. F prime of x equals 3 divided by the product of the inverse tangent of 3x and the quantity 1 plus 9x squared. And that is our final answer for our item number 1. For our second item, we are going to find the first and second derivative of the function. The function r of x equals the cosine of the quantity x minus pi. The function r of x equals the cosine of the quantity x minus pi. We are going to differentiate using the chain rule. Now, if you remember, the derivative of cosine u is negative sine u, and we multiply by the derivative of the inner function, we let u equals x minus pi. The derivative of cosine of a function is negative sine of the function, multiplied by the derivative of the inner function, which is x minus pi. Now we are going to simplify the inner derivative. Simplify by multiplying negative sine of x minus pi by 1. The first derivative is negative sine of the quantity x minus pi. In finding the second derivative, we are going to start with the first derivative. The first derivative, r prime of x, equals negative sine of the quantity x minus pi. Differentiate again using the chain rule. If you also remember, the derivative of negative sine u is negative cosine u, and we multiply by the derivative of the inner function, we let again u equals x minus pi. The derivative of negative sine of a function is negative cosine of the function, multiplied by the derivative of the inner function, which is x minus pi. Now we are going to simplify the inner derivative. Simplify by multiplying negative cosine of x minus pi by 1. Now, the second derivative is negative cosine of the quantity x minus pi. Our first derivative is r prime of x equals negative sine of the quantity x minus pi. And the second derivative of our function is r double prime of x equals negative cosine of the quantity x minus pi. Now, for our third item, a manufacturer's cost function is given by c of x equals 0.25x cubed minus 3x squared plus 20x, where x denotes its output level. Production is increasing at the rate of 5 per month. If the current output level is 50, how fast is the cost increasing? So we are tasked to find how fast the cost is increasing given by the cost function c of x equals 0.25x cubed minus 3x squared plus 20x. The rate of production is dx over dt, and that is 5 per month. And the current output level is x equals 50. To solve this, we compute the rate of change of the cost dc over dt using the chain rule of differentiation. dc over dt equals dc over dx multiplied by dx over dt. To find dc over dx, we take the derivative of c of x equals 0.25x cubed minus 3x squared plus 20x. The first term, which is 0.25x cubed, and the derivative of that is 3 multiplied by 0.25x cubed minus 1, and that is 0.75x squared. For our second term, which is 3x squared, is 2 multiplied by 3x squared minus 1, and the derivative of the second term is 6x. For our third term, the derivative of 20x is 20. So, dc over dx is equals to 0.75x squared minus 6x plus 20. Next, we substitute x equals 50 into dc over dx. dc over dx is equals to 0.75 multiplied by 50 squared minus 6 times 50 plus 20. Now we are going to compute the 50 squared, and that is 2,500. Multiply 0.75 by 2,500 and 6 by 50. Now, we are going to add all the terms. 0.75 times 2,500 is 1,875 minus 300, since 6 multiplied by 50 is 300, and plus 20. Our dc over dx is equals to 1,595. Now, we are going to use the chain rule formula. dc over dt equals dc over dx multiplied by dc over dt. dc over dt equals to 1,595 multiplied by 5. And now we are going to compute this. 1,595 multiplied by 5 is 7,975. Therefore, the cost is increasing at a rate of 7,975 per month when the output level is 50 and production is increasing at 5 units per month. For our fourth item, we are going to find the points of inflection of the graph of the function, if there are any. Determine where the graph is concave upward and where is the concave downward. Draw a sketch of the graph and show a segment of each inflectional tangent. The function is g of x equals the quantity of x minus 1 cubed. To determine the points of inflection and the concavity of the function g of x equals the quantity of x minus 1 cubed, we need to follow the steps. First, we are going to find the first and second derivatives. The function g of x equals the quantity of x minus 1 cubed. The first derivative is g prime of x equals 3 multiplied by the quantity of x minus 1 squared. And the second derivative is g double prime of x equals 6 multiplied by the quantity of x minus 1. And now, we are going to find the g double prime of x that is equals to 0 or is undefined. G double prime of x equals 6 times the quantity of x minus 1 equals 0. X is equals to 1. G double prime of x is defined for all x. So the only candidate for a possible inflection point is x equals to 1. We have to substitute 1 as our x. G of x equals the quantity of x minus 1 cubed. G of 1 equals 1 minus 1 cubed, and that is 0. The function has a point of inflection at 1 and 0 where the concavity changes. So we have here a number line. The positive numbers are located on our right side, and our negative numbers are located on the left side. Now, if the result of the second derivative is positive, we can say that it is concave upward. And if our second derivative is negative, we can say that the concavity is downward or down. For x less than 1, and that is x equals to 0, g double prime of x equals 6 times the quantity of x minus 1. G double prime of 0 equals 6 times the quantity of 0 minus 1, and that is negative 6, which is negative, and it is concave down. For x greater than 1, let us say x equals to 2. G double prime of x equals 6 times the quantity of x minus 1, and that is g double prime of 2 equals 6 times the quantity of 2 minus 1, and that is 6, which is positive, so concave up or concave upward. So we have here our graph of our function g of x is equal to the cube of x minus 1. As for our point of inflection, the graph has a point of inflection at 1 and 0, where the concavity changes. To the left of x equals to 1, the graph is concave down. To the right of x equals to 1, the graph is concave up. As for our y-intercept, the graph intersects the y-axis at 0 and negative 1. So this is found by substituting x equals to 0 into the equation g of x is equal to the cube of x minus 1, which results negative 1. As for our x-intercept, the graph intersects the x-axis at 1 and 0, which is also the root of the function. So for x is less than 1, the graph decreases and curves downward. As for x is greater than 1, the graph increases and curves upward. At x equals to 1, the graph transitions smoothly from decreasing to increasing without sharp turns. So this shows the graph extends infinitely in both directions, with the left side approaching negative infinity and the right side approaching positive infinity. So the graph of function g of x equals to the cube of x minus 1 is a smooth cubic curve with an S shape. So it has a point of inflection at 1 and 0, a y-intercept at 0 and negative 1. For our last item, we are going to evaluate the indefinite integral. The integral of the cube root of x with respect to x. So the integral of the cube root of x with respect to x, so we are going to rewrite the cube root of x as x raised to the power of 1/3. Using the power rule for integration, which says the integral of x raised to the power of n is equal to x raised to the power of n plus 1 divided by n plus 1 plus c, where n is not equal to negative 1. Here, n is 1/3, so we add 1/3 and 1, which equals 4/3. Then, divided by 4/3, which is the same as multiplying by 3/4. The result is 3/4 times x raised to the power of 4/3 plus c. That's all for today. I hope you learned something from me. Thank you for watching and God bless us all.